Hey guys, my name's Anne-Katherine. I'm a second year grad student in the physics department here at UCI. And today I have a video for you all going over the week 7 practice quiz problem number 1. So you can find that in the week 7 module on Canvas. All right, let's get started.
Okay, so as you can see, our problem is written up on the top left here. And I like to start my physics problems with 3 simple steps, and I start every problem with these steps. So the first step is to write down all the given information. So that's what I'm doing right now. So we were told that at t equals 0, our position is 4, 3, and our velocity is 5, 2 meters per second, of course, and that the particle has a constant acceleration of 1.5 meters per second squared in the x direction and 7 meters per second squared in the y direction. We are told to ignore gravity, and that is all the information that we are given. And then we're asked in part A, what's the position of the particle at t equals 8 seconds? And in B, what is the velocity of the particle at t equals 8 seconds also? All right, so the second thing I do is I write down any relevant equations that there might be for a given problem. So in this case, unsurprisingly, my relevant equations are the kinematic equations. Normally, I would write down all 4, but, I looked ahead a little bit and I saw which ones we were going to use. So I'm actually just going to write down the 2 that we're going to use. But in general, I would recommend writing down all 4 just so you have that information there and ready to use. So hopefully this equation looks familiar. I wrote it in terms of r, but we will be using it in terms of x and y in just a second. All right, and then my velocity equation hopefully looks familiar too. Finish writing that down. And then the third step is to draw a picture if applicable. In this specific problem, we don't really need to draw a picture. It would be kind of tricky to draw one because it's hard to know where the vectors are going, since at this point we only know information for t equals 0. So I'm going to skip the picture in this case. All right, so part A, what is the position of the particle at t equals 8 seconds? So we know the position at t equals 0 seconds. Now we're going to use our first kinematic equation to find the position at t equals 8. So we are going to do this in terms of x and y components separately. So we're going to start with x components. So the important thing to remember when you're doing a problem like this is that first kinematic equation that I wrote down, everything is in the x direction. So that includes our initial velocity and our acceleration. That's a really easy mistake to make, to accidentally write down y velocities and accelerations. So just plugging in numbers here, we have x of 8, which is what we're looking for, equals 4 is our x0, aka our initial position in x, plus 5 times 8, 8 again is our time, plus 1/2, and then again be really careful to get that acceleration in the x direction specifically. So that is 1.5 times t squared, 8 squared. And now I'm just going to plug and chug. Hopefully you can follow along. So something tempting to do with these problems is to calculate the magnitudes, or try to calculate the magnitudes of the position, velocity, and acceleration, and then plug those into our kinematic equations. But we really, really want to stick with x and y components. That is the correct way to do the problem, to break it down. And as you can see, I just got 92 meters for my x of 8, the x position at 8 seconds. All right, now I'm going to do the exact same thing for y, moving a little bit faster this time, since you guys just saw the x direction more slowly. But again, being really careful to plug in my y values, especially for that vy0 and ay. All right, so just plugging and checking again here. y0 is 3 meters. Vy0, our initial y velocity, is 2 meters per second, times 8, which is our time, plus, you can see I just messed up that plus sign, but I fixed it, sort of. Our AY is 7 meters per second squared, and again, our T is 8, and that gets squared. So just plugging and chugging here, 3 plus 16 plus 1/2 times 7 times 8 squared equals 224. And then adding all those together, we get 243 meters. All right, so just writing down this information again so we have it before we start part B. So x of 8 equals 92 meters. Y of 8 equals 243 meters. And then we're asked for just two significant figures. So 243 in two significant figures is approximately equal to 240. All right, and that is our position. So just writing it down as a vector here, r of 8 equals 92i plus 240j meters. I could also have written this as 92, 240. That would have also been a correct answer, but I chose to write it in terms of I and j here. All right, for part B, what is the velocity of the particle? So we're basically going to do the same thing we did in part A, but using that second kinematic equation. So again, really important to break it down into x and y components. So doing the x component first here, Vx of t equals Vx0 plus Ax of t. So our velocity x component at 8 seconds equals 5, which is our initial velocity in the x direction, plus 1.5 times 8. We have a little bit simpler algebra here. And we get 17 meters per second in the x direction. And now we're just going to do the same thing in the y direction. So again, this is pretty much the exact same process as we did for part A, just using that second kinematic equation, which is a little easier to work with. So that's kind of nice. All right, plugging in our y values here. Again, it's really tempting to want to just solve for the magnitudes of all of these vectors, but you can't do that. We got to solve for x and y components separately. So please remember that when you're doing these problems. All right, for our y velocity, we get 2 plus 7 times 8, which is equal to 58 meters per second. And we're already in two significant figures here for both our x and y directions, so that's nice. That makes things easy for us. And then just writing this in terms of a vector. Again, I'm choosing to use the I and j notation, but you could just write v equals 17, 58. That would also be correct. But I'm writing v of 8 equals 17i plus 58j meters per second. And that is our whole problem. Hope this helped.